multifunctional fuselage, which has a lot of aspects to take into account, and the large passenger aircraft, ITD. We deal with interior and hybrid seating in aircraft, ITD. We have a connected factory demonstrator here addressed also in the airframe ITD. And of course, we also deal with engines and with systems here represented by typical pictograms here. And here in all of these demonstrator domains, I think I don't need to tell you, it's important to go to the very bits and pieces, to the lifecycle inventories, to collect that, to validate that, and to bring this into analysis. And so I want to give you one example here, which is a little bit beyond circular approach, but which shows how far we need to go if we want to analyze the environmental impact of aviation. So here we took an example from illustrating the chemical loads. There is lots of regulated substances. So for instance, we have the chrome-6 aspect. We have halon as the fire extinguisher, but there will not be any additional halon anymore. So we need to find substitutions, and we need to evaluate that. There are the VOCs, we have cadmium, we have flame retardants, and we have other substances of very high concern here. Basically, in aviation, it's about protecting high-performance materials here, and you need high-end treatments, and they are not always easy to deal with. And we need to understand that. We need to develop the particular skills to substitute and to adapt for this. We have the REACH regulation, and of course we need waste directives here for dealing with these material. And going through all of these aspects in the end, oh, it doesn't go. Okay, oops. Now, if we go all through these aspects, it's about the benchmarking and the analysis and the analyzing of these aspects, and to bring it to a benchmark of the impact. So we will go through all of the technologies to, for example, machining domains, additive manufacturing, we have heard about it. We have the composite manufacturing, we have the recycling and the end of life, and we bring it all together to a life cycle analysis, comparing the indicator sets, and of course we include the socioeconomic perspective into this as well. And yeah, I'm hoping to have some type of continuous platform here, and I would be glad to come back in the future and report more on the progress. Maybe we can have a little bit more than 10 minutes then to go a little bit into depth, but I'm pretty happy to see one or the other representative from you in the future. So
yeah, thank you, Mr. Mullen. And even in 10 minutes, you managed to convince us on the benefits of the eco-design aspects and activities in Clean Sky. Thank you for that. And thank you again to all speakers for the provided showcases. A view on activities, challenges ahead, but certainly I would say a vast will to make a change. Now, this has no doubt triggered some questions from the audience, so in case not yet submitted, feel free to do so. I have two in front of me, two questions. The first one to the chair, based on the information from the first session, he says that aviation has been circular with high rates of reclaimable aircrafts. Aren't we creating the problems by moving to composites? All the projects seems to be concerned with solutions for composite circularity challenges. Why not move back to alloys as materials? I can take liberty to ask or to comment on that. And Jürgen, if you want from Sustainer, you can add if required. Yes, composites do know their challenges for recyclability, but they're being worked on, and some of them are industrially established. And let's not forget, and you're right, it's a trade-off between a fully recyclable aluminium alloy, let's say, and a bit more difficult to recycle composite solution. But let's not forget, if you use composites, you typically have a weight saving of, when transferring aluminium to composites, about 25% weight gain. And this has an associated reduction in fuel consumption, right? So yes, you have composites which are a bit more difficult to recycle in the end of life, let's be honest. But it's being worked on and will be fixed, I would say. But in the 25 until 30 plus years of the complete lifetime of the aircraft, you have flown an aircraft with less weight and hence much less fuel consumed. Okay, and this is a trade-off that always has to be made. Jürgen, feel free to comment or add something on that if required.
Okay, so thank you, Stein, for that. Of course, what I should comment, of course, in Sustainer, we focus on on the second life of materials, not only on composite, but of course the main focus is given on composites, on thermosets, thermoplastics, and so on. And this we are working on. And of course, we have metal. We will always have metal parts on the aircraft, and we will have some combinations between a composite and a metal. And therefore, we are working on a new strategy how to combine both materials, and then also how to dismantle both materials. And of course, in the case of titanium, we are also developing some strategies to recycle these powders and things like this. And of course, so I think we really provide a huge or a broad overview how we can recycle all kind of materials we are using here on board.
Mm-hmm. Thank you, Jürgen. A second question I received is for Mr. Megbal from the Morpho projects, asking what are the sensors currently used to create those digital twins you described, and how do they differ from the current GE engine digital twin?
1 second. Okay. Can you please just repeat the end of the question? What are the different from them?
Yeah, so the question was what the sensors that currently used to create those digital twins. I think you described them in your explanation. And how are they different from the current GE digital twin practices?
What we are planning to use is some two kind of sensors. The sensor that will be typically used for the RTM process. This is for the manufacturing. Just to optimize the manufacturing, and the others will be some sensors that will be embedded during the manufacturing, like fiber brag, something that it's not different from what it's used now, but just it will be embedded in the manufacturing process. And the others will be some printed sensors, so lightweight printed sensors, and all the system, all the electronic system will be printed. So it can be, this will be done by a colleague from IFAM, and this will not have any impact on the certification of the fan blade or stuff like that, because it will be printed.
Mm-hmm. Yeah. Okay. Yeah, thank you, Nazif, for that answer.
You're welcome.
Now, the speakers and panelists are asked, if possible, to put on cameras to take a group picture of this event before we adjourn. Michaele, if that all is okay, give you all to say that we're okay to do that.
Yeah, it would be great if the panelists and the speakers could turn on your camera so we can do a group photo.
Yeah.
So let's just take a couple of seconds for everyone to set it up, if possible.
Yeah, there we go.
We're almost there. Another second. Maybe if Sonel is still here, I see. Okay, so let's do this. 3, 2, 1. Give me a second. All right. Okay, that's that. Okay. Thank you so much for now.
Very good, very good. Okay, well, thank you to all speakers for providing us a view on some developing technologies that will bring the circular aviation closer to reality. I will now hand over to Jürgen from AIT again for a final closing word of this circular aviation event. Thank you very much.
Thank Yeah, thank you very much to all. Thank you very much to you, Stein. So, what should or what can I say? So I really say thank you very much for being part of this event. It was a great event. It was, yes, we tried to make something new with a panel discussion and things like this. And so I think this worked quite fine. And I really want to have it, as Thorsten already mentioned after his talk, maybe to repeat this in the future time. So here we were interesting panelists. We had interesting panelists. So this would be great that to stay in contact and to involve these organizations like AREA, SAMPE, Clean Sky, and key companies in the field of aviation, such as we had today JetMS or Airbus, of course, for some future common workshops or things like this, together with the three projects which were funded from the same call, the Morpheo project, the Dominio project, and the Sustainer project, and all these contributors. And also thank you very much to you, Ux. This is our project officer of the three projects, for contributing today, for being part of this event. Thank you very much. And of course, it would be a great pleasure to also have Fraunhofer with the eco design, with some new results on board in a future workshop or future event. And so it was really a great pleasure to me to be your moderator, to be your presenter. Thank you for your interest. Thank you for attending. Just one thing, last but not least, many thanks to Michaela and to Stein for your professional support during the event. So it was a great pleasure for me to collaborate with you, and we can repeat this in future time. And also many thanks to all participants. We were a quite huge around of a group of people which were interested in this topic of circular aviation. So for me, we are a little bit overdue, but for me, I say thank you very much for participation. Thank you very much for everything. And now I want to close this event and say goodbye, and hopefully see you very soon. Thank you very much. Bye-bye.
Bye, thank you.
Bye-bye. Thank you very much.